Python 2, map not equivalent to list comprehension in simple case, length dependent. In Python 2, the built-in function map seems to call the _len_ when length is overwritten. Is that correct? If so, why are we computing the length of the iterable to map? Iterables don't need to have length overwritten, for example, and the map function works even when length is not predefined by the iterable. Map is defined here. It does specify that there is length-dependent functionality in the event that multiple iterables are passed. However, I'm interested in the case that only one iterable is passed. Even if multiple iterables were passed, not my question, it seems like an odd design choice to explicitly check the length, instead of just iterating until you run out and then returning none. I am concerned because according to several 1-2 extremely highly upvoted questions, mapf, iterable, is basically equivalent to fx for x in iterable. But I am running into simple examples where that isn't true. For example, behaves as it should, but if you uncomment the overloading of len, it very much does not. In this case, it raises an attribute error because the iterable is none. While the unit behavior is silly, I see no requirement of invariance in the specification of len. Surely, it's good practice to not modify the state in a call to len, but the reason should not be because of unexpectable behavior in built-in functions. In more realistic cases, my len function may just be slow, and I don't expect to worry about it being called by map, or maybe it isn't thread safe, etc. Implementation dependent? Since map is a built-in function, it may have implementation-specific features outside the spec, but Python implements it on line 918 of built-in module.c, which indeed states, and then calls _PyObject_lengthInt, which is defined in object/abstract.c, and indeed seems to look for an overwritten len. This doesn't clarify to me whether this is just implementation dependent, or if I'm missing some reason that map purposefully looks for the iterable's length against my instinct. Note I haven't tested this in Python 3, that is why I specified Python 2. In Python 3, map returns a generator, so at least a few of my claims aren't true.
I am concerned because according to several 1-2 extremely highly upvoted questions, mapf, iterable, is basically equivalent to fx for x in iterable, but I am running into simple examples where that isn't true. But calling _PyObject_lengthInt is supposed to be basically equivalent to not calling it. And objects _len_ or _length_hint_ is not supposed to mutate the object like this. You might as well say that mapf, iterable, and fx for x in iterable are inequivalent because if f uses stack inspection to determine whether it's being called from map and does something different, the two snippets behave differently. As for why map does this, it's try and pre-allocate the list to the right size to avoid needing to resize the list. Resizes only slow things down by a constant factor, but if you can avoid the constant factor, why not? It would be perfectly reasonable for list comprehensions to do this in a future Python version.
I'm not quite sure of what you're asking here. I'm going to assume that your question is why is the result of mapf, iterable, not always equivalent to fx for x in iterable? From your research, it's clear that there is degree of implementation dependence in the built-in map function, which, while it does come off a bit strange, makes total sense for a custom implementation of an iterable object. The point of the specification of the _len_ being a bit too lax is a good one though. It seems that modification of object state should be labeled as very bad in a method like this. However, it does seem like your interpretation of the equivalence between mapf, iterable, and fx for x initerable, might be making incorrect assumptions. This is true, of course, in cases where the implementation of f, map and iterable do not modify the underlying mechanisms of the evaluation. When they do, all bets are off. Basically, context is important. Take this, for instance. Here, obviously, the map function result and the list comprehension are not the same thing, if you only look at the last two evils. Heck, they do completely different things. This is completely due to context. Therefore, unless clearly stated, in most cases it is completely reasonable to assume that both map and iterable's implementation do not circumvent the mechanisms in Python. However, if there is context, it comes first.
If you want to get anywhere, gracias a Unforgiving.